All right, everyone, let's get the show started. Welcome to Office Hours. It's March 25th, 2020. My name is Eric Osterman, and I'll be leading the conversation. I'm the CEO and founder of Cloud Posse. We are a DevOps accelerator. We help our companies own their infrastructure in record time by building it for you and then showing you the ropes. For those of you new to the call, the format is very informal. My goal is to get your questions answered. If you want to, jump in and participate, feel free to unmute yourself at any time. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to the Office Hours channel, as well as follow up with an email so you can share it with your team. If you want to share something in private, just ask and we can temporarily suspend the recording. With that said, let's kick things off. There were a bunch of questions brought up today in the Office Hours channel. I thought we could use those as a starting point for some talking points. First, I want to, of course, start with getting your questions answered. So any new questions from the community?
Good evening. My name is Gareth Frost. I'd like to understand if your Jenkins suite of Terraform tools that build full end-to-end pipeline are all complete, or is there additional work that we would need to do?
All right. So if I am getting your drift, you're talking about this Terraform module?
That's correct.
Gotcha. So this, I'll say that we don't typically use this module regularly because we're mostly using CodeFresh. We have kept it up to date as recently as 5 months ago. And not only that, we have added the Terra tests to this module to validate that the server comes online and is functional. That said, and then there's two pieces of this, right? So there's this Terraform module here, and what's unique about our Jenkins module, or our Terraform module for Jenkins, is that it does CICD of Jenkins itself using code build and code pipeline, so it's a little bit meta. And then there's the Jenkins Docker image. Now, we are not, as you can tell by the age of that, we're not actively investing in it because we don't support, none of our current customers are actively using it. Also, we're moving more in the direction, we're actually doing a project right now with Jenkins, but we're going to be deploying Jenkins with Helm on Kubernetes instead. So this approach, I think, is valuable for those who don't want to run Kubernetes, but it's not the one we're investing in.
Okay, thank you for that. Looking at the architectural diagram, and apologies, I'm no expert in this particular area. I've gone through the Terraform code and I can understand most of this, but the one bit that seems to be missing is the slaves configuration. Am I missing that, or is that something that we need to build ourselves?
So yeah, that's a good question. So we, as you see in the annotation here, this was designed for us that you would then point Jenkins at a Kubernetes cluster. So you might wonder why okay, so first of all, if you're not using Kubernetes, it's kind of moot. You'd have to do something else. In our thinking, why we created Jenkins as a standalone instance in Beanstalk running outside of Kubernetes was so that we could run the GitOps, the commands to administer Kubernetes itself, so that basically Jenkins could rebuild the Kubernetes cluster if we wanted to. So one way is to have the slaves running as EC2 instances, which there's just a plugin for that, and the other is running those slaves as pods under Kubernetes. So if we go to Cloud Posse and search for Jenkins, I just want to point out one thing. So there's newer, better ways of doing this. There's like Jenkins configuration as code. This is not using that plugin. This is using just straight up Groovy. I wasn't the one who implemented it, so it's a little while. I'm not as fresh on it. But the idea is with this Groovy, here's how you can initialize, I believe, Groovy with EC2 instances as the workers. And then I think there's, I think I'm maybe mistaken. Anyways, look over this Jenkins container, because the Jenkins container is the one that sets up everything for that. And if you look at the plugins.txt, these are the plugins that it installs out of the box. So if one adds there's an AWS plugin for running slaves on AWS. There's also a plugin for like using code build, I think. So there's a few different options there. Anybody else have more to add to this? Anybody else maintaining Terraform modules for Jenkins?
So thank you very much for that explanation. If I was to put you on the spot and say, whilst you guys are doing limited maintenance on this, as a company that may be looking at this approach probably for the first time to get to roughly what your network diagram displays and the flexibility that we believe that brings to the table for us, and I should state now, traditionally my company has pretty much had EC2 machines that have just been terraformed and standalone Jenkins machines. So to us, this is much more of an improvement. Would you advise not going down this road and looking at some of the other Jenkins modules you've mentioned and steering away from this because it's old hat, to sort of put a phrase on it?
So two things. I mean, if this is something that's going to be in the critical path for your business and something you're going to want to extend or customize, I would probably start by forking the module and then customizing it to your needs therein. Also, just one thing I was just checking here. We've also updated this, so the data pipeline to do backups has been simplified now because AWS backups came out since we did this diagram. So now the backups here is done with AWS backups. So to answer your question though, like would I recommend this or something else? I'm not sure. I haven't done any research on Jenkins Terraform modules. When we implemented this, it was like back in 2016 or something, at least 2 years ago when we started it. I think earlier than that though.
It seems very bespoke to a particular, you guys decided that you wanted to build Docker images using Jenkins, save it to ECR, and deploy it to Elastic Beanstalk. And if someone else wants to do something different for any of those, then this doesn't work for them.
Right. No, I mean it's opinionated, as is a lot of the modules. But here's the thing: is like you want to deploy Jenkins to AWS. I guess you have three options, high level, right? You could do Fargate, you could do EKS, or you could do Beanstalk, and then lastly, you could just roll your own EC2 instances. If we go the roll your own EC2 instances, then we have to invent the whole deployment strategy for that. So the reason why we went with Beanstalk is Beanstalk has the concept of rolling updates, has the concept of integrating with code build and code pipeline to do the deployments. The other thing is if you roll your own, you have to come up with a strategy of how do you update Jenkins itself. So I like the idea of having a Jenkins container running that, and then you can actually develop and work on that Jenkins container locally if you want. So, I mean, I think there's, and then sometimes, to be frank, I use this as an example of why you shouldn't use Jenkins. Not why this is a bad architecture. It's just saying if you take this to the extreme, this is like a best practices implementation of open source or community edition of Jenkins on AWS. And let me explain why that is. So you're deploying, in this case, in ELB for the traffic. You need to have TLS terminated at that. So we set that up, and then you want your access logs. So we have those going to the bucket, but then, you don't want to have those access logs persisted forever. So we life cycle those out to Glacier and then ultimately delete them. And I mean, that's a lot to do just right here. And we haven't even come to deploying Jenkins yet. And then we deploy Jenkins, in this case with Beanstalk. Look, legacy technology, but hey, it does the job, and and automates your classic application architecture where you have multiple nodes and then fronted by a load balancer. In this case, Jenkins master instances, you can't have more than one. You can only have one online at the same time, or you risk corruption of the file system. But if you wanted to be able to do rolling updates, even if that means going down to 0 and then back up again, we need to share the file system. So the easiest way of doing that is using EFS as that file system. And then we also don't need to worry about the file system running out of storage. But okay, now we deploy EFS, we need to have backups of that. So how do we do backups? That historically was a real pain in the butt where you provision a data pipeline. Data pipeline has like some Lambda that runs AWS S3 sync and syncs those to the EFS bucket, and then all the lifecycle rules on those backups. Now that's simplified using the AWS first-class service called AWS Backups. All right, and then we got how do we update Jenkins? So one thing is getting Jenkins deployed. How do you keep Jenkins up to date, infrastructure as code-wise? And that's what this is solving. So the idea is that you have the code pipeline and code build and ECR to do that. Again, staying within the Amazon ecosystem. Now, if you wanted to use GitHub Actions or Circle CI or that, that would be a totally different solution. So what we tried to do here was implement using almost strictly AWS services, this implementation.
Thank you for that. It's very useful.
Question.
Yeah.
I would say.
What do you use to build your diagrams right there?
Oh, so this is Lucid charts.
Lucid? Okay.
Yeah, they've got good AWS and Azure and GCP, graphics and everything.
Okay.
I would say Kubernetes makes this easier nowadays.
Totally. Yeah. So I mean, Kubernetes. I mean, once you get over the hurdle of deploying and setting up Kubernetes, which is its own roadblock, but once
like
you
the whole
understand that,
TLS termination thing is let's encrypt.
line.
Yeah.
Add an annotation.
Yeah.
So yeah, this gets radically simplified if you use Kubernetes to run and manage it. But it introduced new complexities, like if you're running Jenkins under Kubernetes, if you're building Docker images, that suddenly is a lot more complicated, and you need to use one of the alternative Docker bundling tools.
Okay, thank you for that. That's a lot of food for thought there.
Yeah, a lot of food for thought. Cool. Any other questions? Doesn't have to be related to this. Just in general, DevOps.
I got a question, actually. Yeah. So I'm working with Kubernetes and trying to figure out how to manage certificates, and I came across a project called Cert Manager.
Yeah. And
started using that. Is that pretty much the way to do it? It's the first one I just happened to come across.
Yeah, that's the canonical TLS certificate management software. It's based. So I believe it's JetStack that manages that one, and they built the first one, which was called KubeLego. KubeLego is now end of life and has been superseded by Cert Manager. And Cert Manager does a lot more than just Let's Encrypt certificates. It can also be your CA, your certificate authority, and help you with PKI infrastructure if you need to do self-signed certificates for services for like MTLS inside of your cluster.
Okay, how does that new certificate feature I saw that's coming in Kate's, what is it, 1.18? I think they announced something with certificates. Did anyone happen to see that?
Yeah.
Is this for though secret encryption, or this is?
There
were people. Kubernetes has an internal service for certificates, for provisioning certificates for etcd and for whatever, for internal services for Kubernetes, and people were using it even though it was like, hey, this is really not meant to be used, but people were using it anyway. And so they saw, that people were using it and went, hey, we can let's go ahead and make this a public API that and kind of bless this.
That's cool. Yeah, to be honest, I was not aware of that. So
yeah, I saw the same thing from Sysdig that you're looking at now, and at the same time that I happen to be working on Cert Manager, and then I'm like, oh, what's this coming down the pike? Is this going to change how things are potentially done in the future? It sounds like maybe, I guess, if you wanted to use the root CA that's in the cluster.
Yeah, or I see it maybe replacing the PKI stuff, but I don't see it replacing Let's Encrypt. So what are you using Cert Manager for now?
Just actual certs on the ingress controller.
Okay.
Yeah, so you're going to want to use like Let's Encrypt to do that,
okay.
so that when someone's hitting your ingress with a browser, they don't get this cert is not trusted or whatever.
I see.
The only way to get that green lock is to use a trusted root CA, which is what Let's Encrypt is giving you.
One thing I really wish is that AWS would add the Acme protocol for TLS. I remember.
Yeah, that'd be really nice.
Yeah, I remember doing some research for this, and I don't remember exactly what I was searching for, but basically, I love Let's Encrypt, and I want to continue using Let's Encrypt. But they, and if I could pay to raise those rate limits, I would pay that in a heartbeat. But they don't even provide a way to pay for better service if you need it. So that's why I really wish there was any other, official CA that provided Acme protocol without rate limits. That'd be cool.
Yeah,
Cert Manager's not.
DNS validation right now with Route 53. Actually, I've got Cert Manager creating the records necessary in the Route 53 zone for validation, because all of this is on a private network.
You're using external DNS for that?
Yeah. We can't use the HTTP endpoint because it's all private. So
yeah.
Cool.
You were saying something, Andrew, briefly?
Cert Manager is not the only option. If you're using like Istio will do it too.
Oh.
There's like Glue, I think, that'll do it. Most of the more of the full-featured ingress options will do certificate, TLS termination too, which has certificate management. Istio's is called, right now it's called Citadel, I think. If you search Istio Citadel, I think you're going to find it. But it's getting rolled into another service. The Istio guys are simplifying their architecture a little bit. Yeah.
That makes sense.
Well, that's something else I'll have to take a look at later. We're not using Istio right now. Just
Istio's really awesome, and it does a lot of really cool stuff. But it's definitely you pay the price with complexity, because it definitely adds complexity.
Yeah.
Yeah, supposedly they were to make it simpler by just throwing everything into a single daemon, as opposed to having all the parts spread out, right, into just like Istio-D or something.
Yeah, but like there's a couple of really good reasons to use Istio that, if someone tells you, oh, Istio's not worth it, you don't need it, you can tell them to shove it. And like one of the perfect reasons is the mutual TLS that you get. So like we recently had to set up Keycloak with OpenLDAP as the backing for the user database, and we the guys were digging down this rabbit hole trying to figure out how to get LDAP-S to work so that you could securely do, through Keycloak, you could, if I'm a user and I go to my Keycloak and I want to change my password, it makes a secure connection to LDAP to change the password using, TLS to do that using LDAP-S. And they're going, oh my God, we're having such a hard time getting this to work. We've got to get it to figure, we've got to figure out how to get these guys to, get OpenLDAP and Keycloak to share certificates and manage those certificates and whatever. I'm like, hang on, stop, wait. Just turn on Istio Mutual TLS, and you've got a frickin' steel tunnel all the way through that is solid. Don't worry about LDAP-S at all. Have an unencrypted LDAP connection that is encrypted by Mutual TLS through Istio. Bam. So that's why.
It's magical when it just comes together like that.
Cool, thanks.
Any other questions related to this or anything else?
I posted a question. So the last 2 days, I had a couple of issues with commissioning EC2 instances, in particular C5X large in EU Central A1. They just didn't start up. There's a thread in Slack as well. I posted it with an image of the error message. I'm just wondering if you have knowledge where I can find out if something, there's also an image in the thread if you click the link. How I can basically find out if instances are available. I'm new to AWS. I was Azure all the way before, so.
That's interesting. I don't. It's a legit request, and you should be able to have an alert for that. I know that.
Not answering your question, but are you able to spin up a different type of instance if that one's not available?
Yeah, I was able to. I just it's our GitLab runners, and we didn't care about multi-AZ in this case. So the same instances were available in EU Central A, B, and AC. So, but in general, I don't know how to do it, and I'm currently wondering if I should introduce in our autoscaling policies or autoscalers in AWS a mixed instance policy. So
yeah, so if you do, that's what I was going to kind of get at. If you do a what are they called? A template, a node template, or whatever.
Template.
A launch template. Yeah, you can have a priority list of instance types. And it'll try your first priority first, and if it can't because they're out, it'll do your second priority.
Right. So yeah, that's what I'm this is what I'm currently evaluating if it's worth it, because all three zones being out of instances seems unlikely to me. But in the case that it happens, the instance state doesn't change if you try to spin up new instances. You don't get a notification. I don't know what's going on there. I don't have any insights, which is kind of weird. We also just noticed it because, well, our pipelines were not working anymore. So it's the only reason why for us, we actually noticed it.
Yeah, I don't even know if there's an API to be able to check if that exists without trying to launch it itself.
Right.
This is the thing I was thinking of. I just wanted to see if they had any mention of the problem that you're talking about. So this is a set of lambdas you can deploy to monitor your AWS limits, when you're approaching them, and get alerted on that, which is also valuable. But I don't know if this is going to tell you, you can't even launch the instance to begin with, even though you haven't reached your limit on it. Maybe.
Yeah, it was not my limit. It didn't work on any of our 4 accounts. So it was just AWS, this particular zone didn't have any instance of this type available.
And you'd previously been able to launch them?
Yeah, it also worked when I switched to instance type, and in the afternoon I switched them back to a smaller one again, and that also worked. I just could not spin up C5x large. Like for me, I'm new to AWS. Like I said, it's just like
Yeah, I mean, they only have a certain capacity of bare metal servers.
sure, yeah.
You know, and I mean that's where, you know, spot instances come from, is you're buying extra capacity for cheap, right? So there could be something in spot instance availability that you could look into. You know, that if spot instances aren't available, that means they're running out
Okay.
of you know, of that type of resource.
Sure.
So, and the other thing to consider are spot fleets, which then can be composed of multiple instance types. So don't. It's almost like treating instance types as cattle as well. Don't rely on just one type of cow.
Right.
Have many
Yeah.
cows.
Right. Yeah. So that's what I'm currently like thinking about, if I should do it, if it's worth it. Because, well, for one particular service, we like spin up between 20 and 100 instances throughout the day. And, well, if we cannot spin up more instances, we kind of are in a bad shape in terms of performance and stuff. So,
yeah.
But yeah, cool. Checking spot ins might be a good indicator. Thanks.
Cool. Just going to see here. So Jeffrey and Ben, do we have Jeffrey or Ben on the call?
Yeah, I'm here.
Hey, Jeffrey. Glad you made it. Well, why don't we get to your question here, Jeffrey, then. The best way to do multi-region with Terraform on AWS. Let me bring up your thread that you had posted so everyone can get the context here.
I could also just repeat as well. So basically what I'm looking at is to have disaster recovery for Terraform. Essentially just a duplicate set of resources. Like we have a Kubernetes cluster, and we use like all of S3. And then so we're primarily in the US East 1 region. We want to have a failover into, my example is just US West 2. But then, so what I was worried about is managing the Terraform remote state in S3, because given that AWS's S3 buckets are region specific, if let's say my initial attempt was just to have everything in US East 1 managed by a bucket that was in also US East 1, and then to basically split it out that way. So a bucket in US West 2 would also manage all of the US West 2 resources. But then if you actually have an entire region going down, and also in between, we also have to read from the Terraform remote state as a data source. That way, I mean, because it's like, for example, if you want to replicate a database from the source, then you also need to just be able to know the Amazon resource name from the other. So, but then if a entire region goes down, then I imagine the S3 bucket would be inaccessible. So my next thought would be just to have a single S3 bucket that manages all your regions, and I mean basically whatever regions that you also have resources in. But then you would have kind of like a cross-region replication of that bucket into somewhere else. So in the case that a region actually goes down, you can basically just point it to the bucket in the failover region.
Well, yeah, that's a great summary of the problem and what you mentioned there. Two thoughts come to mind. First is, I think thinking of it in terms of failover is a fragile approach, that you should think of it in active as much as possible. Now, that might mean you run smaller sizes of your workloads in those two regions, but that you are actively testing them all the time. Because what happens so frequently is you fail over, but if you're not running real workloads on there, you don't really know that it's a viable alternative.
Yeah, so that's something that I actually did want to do, but under the direction of like kind of our management, they want the capability to have a failover. That's just based off of some regulations with some banks that we're working with. But then to actually just kind of like just turn off that capability until like further down the line. So at the moment we can't have like an active setup.
Then I'd like to propose another kind of, let's say, wild or wacky idea, non-technical solution really to your problem. The idea is to phase shift. And what you want to do is ensure that failure of one system isn't coupled in some way to the failure of another system. And well, what about just not using Amazon as your state storage backend for Terraform, therefore?
Yeah, that's possible. I mean, other suggestions, like I know, like for example, GCP, like their data storage is like multi-region. I mean, I guess that's an advantage there. But I mean, like, what other? I guess, do you have any suggestions?
Well, yeah. So that was the one suggestion. The other is though, and I mean, I still, as much as possible, I think you should still keep the state storage bucket totally separate and isolated per region, and that regions more or less share nothing, with the exception of some things that you mentioned, like VPC peering connections. Where does the state belong for that? And then like setting up database replication. On the other side, you have the failover capabilities of the product, like the front end, and ideally you'll be able to address that just based on the health check capabilities of Route 53 or whatever system you have sitting in front of that, so that traffic will automatically fail over to the available region as necessary. Now, if you need to do some operation like promoting one database to be primary, I think that's going to depend on the technology, and that's where you're going to have to be most careful about where that state is stored, that you're not in a pickle on that.
Yeah, and that's kind of exactly it was during the process of kind of like restoring, or I guess promoting the read replica up to a master database, and eventually like reverting back, is where we ran into that, where because the thing is, like, even the resource name, we still have to be reading from the remote state. And then at some point when we want to, let's say the region
the remote
comes back
state
up,
should all be internally consistent. So remote state in US East 2 should always be reading from other remote states in US East 2. Never remote states in US East 1.
I see. Okay.
Yeah.
Okay.
So that means that to bring up this infrastructure in US East 2, you have a parallel set of resources in that region, and parallel state files and all that.
Okay. So essentially just like a cross-region replication.
Replication has kind of some loaded, concepts with it, that things are getting, like, there's some process replicating it. That's not what I'm saying or suggesting. I'm saying that you actually have the ability to spin up the parallel stack in the other environment, of which most of it maybe you have turned off for whatever cost reasons, and then you have your replica, a database that's turned on. Now, there's also Postgres, Aurora has their global database now. Don't have firsthand experience with it, but this seems to address part of that use case that you have. And they support Postgres, and is it MySQL 2 now?
MySQL 5.7, I guess. It's
Okay.
not MySQL 8, but 5.7.
Yeah. So you might be paying a price for running that, but I mean, it's probably going to be less than the engineering cost of instrumenting your own system.
Yeah. Okay. All right. Yeah, that makes sense. Thanks a lot.
So what do you, real quick, what are you proposing with Aurora?
Well, so they have, just like Microsoft offered with the SQL database, they have now a global database, so it should support regional failover, or the situation where a region is offline.
And then how were you applying that to Terraform?
Oh no, he's just saying so that I wouldn't have to have like a source and failover RDS where one gets promoted in case that a region goes down. So it basically just handles all of that failover.
I see. Okay.
Yeah. And Route 53 is global, so I presume the endpoint for the Aurora global database, that endpoint would work in en route to the appropriate region.
Yeah, makes sense. Okay, cool. Thank you.
Yeah. Cool. So we covered that one. All right. So an interstitial topic. I thought this was pretty rad. Slightly disappointed, but I get why they did it the way they did it. So one of the nice things with Kubernetes is it's like this API where you can just throw documents at it and it creates it for you. Kind of like CloudFormation, but genericized. And then there are operators to add the business logic to do whatever you want. Well, Terraform, therefore, would is this gap. Like, it would be awesome to be able to just deploy a document to Kubernetes that describes my RDS instance or something that I want to deploy, and then Kubernetes handles the scheduling and provisioning and creation of Terraform to do that stuff. So there's been a few attempts at doing this by other companies, by other people. Basically, Rancher had one. Let's see. Lauren brought this question up again recently, and I'm just going to pull this up. So, or not Lauren. I mean Ryan Smith. So AWS has like their service operator, which is kind of a wrapper for calling CloudFormation. And let's see where. Yeah, this was a link to the one that Rancher had. And these all allow you to just use Terraform open source to provision Terraform code on Kubernetes. But now HashiCorp is coming out with a first-class provider for this, or not a provider, I mean operator for this. And it works in tandem with Terraform Cloud. So basically, it triggers the runs to happen on Terraform Cloud for you, and then Terraform Cloud can handle the approval workflows and exception handling and triggers that happen. Like if this project runs, then trigger this other project, which would be really difficult if they had to re-implement all of that inside of Kubernetes. So that's why I get why they're making this integrate type with Terraform Cloud. Is it clear kind of what the value is of what this operator is providing for Kubernetes? I can go into more detail. All right. So yeah.
No, it's not clear, but my understanding of Kubernetes to begin with isn't all there, so I will not.
I like to. Yeah, I like to think of Kubernetes as a framework. Two things. It's a framework for cloud automation that's genericized across providers, as Spring is to Java, as Rails is to Ruby, as Kubernetes is to cloud almost. And then it's another thing. It's a new generation of operating system. So what are the characteristics of an operating system? An operating system has a kernel that does the scheduling. Well, Kubernetes has a scheduler. That's kind of like that concept, but it treats nodes. It can distribute those workloads. Another characteristic of an operating system is it has a file system. Well, Kubernetes has a primitive for a file system. Operating systems have primitives for configuration, like etc, right? That's where you have typically all the configuration. Well, Kubernetes has config maps. And the analogs go on and on and on and on. So if you work within Kubernetes, within the bumpers of Kubernetes, then you can achieve automation much easier. So that includes like the problem with Terraform that we have today is how do you orchestrate the actual business logic of deploying a module? Like if you wanted to do blue-green with Terraform, where does that logic of blue-greenness go in Terraform? There is no place. Or you could write your own Terraform provider to implement blue-green. Or you could do wiki ops. Basically, you describe in a wiki page how you do blue-green with your Terraform code. Or you can script it with Ansible. Or you can script it with some bash script. Or maybe the future is actually orchestrating that stuff more with Terraform. No, sorry, Kubernetes and Kubernetes operators. I totally missed the punchline there.
So to kind of like make sure I got understand what the value add for this HashiCorp offering is that through this operator for Kubernetes. Now, I don't know what the difference is between an operator and a custom resource declaration.
Operator implements what the custom resource definition describes.
Okay, thank you. So I guess what I'm saying then is that you could take this operator, apply it to your Kubernetes stack, and then give it whatever credentials it needs, and then you supply a manifest saying like, hey, besides this app, I also want to run this, I don't know, Amazon global database Aurora instance, and so when I spin up my app, it says like, hey, by the way, before you do this, I need this DB. It does that. Like Kubernetes reaches out to AWS through Terraform, creates that Aurora instance, comes back with the endpoint, feeds it into my app, and I have a running app backed by Aurora, all through Kubernetes.
Thanks.
Did I get the picture?
Yeah, thanks, Jim, for bringing that up. That's a really good point. So, like when you deploy your apps to Kubernetes, like here's an example app we have under Cloud Posse, and we're deploying this with Helm file. Now, if you're not using Kubernetes or Helm file, that's not as helpful here. But I wanted to point out some things that are happening here. One is that we're deploying here a CRD for a gateway. This is just a generic gateway that happens to be for Istio. Here we have a virtual service. And well, what I could add below here would be a CRD for Terraform. So here, Terraform, provision this module for me for RDS. So now we have one document language that handles the configuration and deployment for everything Kubernetes and everything outside of Kubernetes. And we can package all of that up then in a Helm package. And we can actually have then a Helm package for our application that spins up our services in Kubernetes, our backing services with Terraform and RDS. It provisions the IAM roles with Terraform, and it deploys this cloud formation from our third-party vendor, all in one thing.
What are the implications of this being Terraform Cloud as opposed to, say, open source Terraform?
No first-hand account, of course, this just happened. Looking over the announcement in the video, the main thing seems to be that it triggers two things. One, state storage. It works with the Terraform Cloud state storage. So, well, if you're not using that, that's going to be a deal breaker. And then two, the next big deal breaker is it works on the concept of remote runs. So with Terraform Cloud, it's really cool. You use the client to trigger runs in the cloud. So even if your client disconnects or you close your laptop or whatever, everything keeps running and you just reattach to it in the cloud.
And that removes the need for managing, like I think you already said this, but managing state at all, whether it be your S3 backend.
Yeah.
Terraform Cloud is just doing that for you, right?
Makes it a black box more or less to you. And you don't have to worry about corruption of that, securing of that, all that other stuff.
Quick question, as you've touched on Terraform Cloud, when you're using something like a local exec part in Terraform, where you'd normally give it something like sh, whatever your command might be.
Yeah.
My team operate in multiple OSs, Unix-based and Windows-based. That's always been a challenge for us with that type of thing of ensuring we get the right type of commands.
Yeah.
How do they handle that in Terraform Cloud?
I can answer it as much as I know from our experiments. Also, if, let's see here, John is online. John's not online. All right, so to date, my understanding is that Terraform Cloud only supports Linux like runners, and those are hosted. So the Terraform command local exec runs in that Linux shell. The other problem is that they don't allow to bring your own container. So you're restricted to the commands that exist in that container. So that's why what some people do is you have a local exec that goes and downloads the AWS client. You have a local, excuse me, you have a local exec that goes and downloads some other binary you depend on. Then the other way it works is that you, it has the convention that you, in your .terraform.d folder, you add that to your source code, and in there you can stick any providers that your module, excuse me, that your modules depend on.
Okay, thank you.
So that partially answers your question. That's how it works for Linux-based plan and applies and stuff like that. I don't know if Terraform Cloud has a solution that works on Windows yet, but I'm guessing just as a observer of this, I'm impressed and surprised by how much Terraform is happening on Windows and started on Windows workstations and Windows environments, because it's something I haven't touched in 15 years.
Yeah, I'm equally surprised, and I look at my colleagues who use Windows daily and say, how?
Sorry.
But there's some, I mean, I have nothing but respect for Microsoft these days. They've really turned a corner in my book in both supporting open source, providing awesome tools. I mean, Visual Code is arguably one of the best IDEs out there. The Windows subsystems for Linux, that's pretty cool how they strap that on, and I think they've even made that more first class now and improved. So yeah, I get how it's possible, and it's cool. Cool.
They call it the Nadella-sans.
Or what are they calling it?
The Nadella-sans.
Nadella-sans.
Yeah.
You'll have to unpack that one for me. I don't get it.
Satya Nadella is the new CEO.
Ah, of course. Okay, got it.
And he's turned the company around.
Yeah, that makes sense. All right. Well, then a personal shout out here. If you guys wouldn't mind, nominating me for a HashiCorp ambassador, that'd be pretty awesome. I know I've reached out to some of you directly, but I'll share this in the Slack channel. I think that would help us reach more people, so your nomination would be appreciated. So I just sent the link to that in the Office Hours channel. All right. Then another one. This is a, I don't know if I'm going to be able to answer it in a way that's going to be satisfactory, because I don't think we've solved it. I don't know if anybody's entirely solved it. But Ben was asking in one of the channels, and I shared, cross-posted that link in Office Hours here to his question, this one. So, hey folks, I'm looking for some advice on how people are tackling the chicken and the egg problem with secrets management. I had the idea to use Terraform to provision Vault, but with this comes the question, where do I get the secrets needed within Terraform scripts? Of course, I do love to use Vault for that. One solution I've heard is to place the TF scripts in a super secret Git repository, along with these secrets, restricted access to only a select few. While I guess this works, something about it feels dodgy. But I guess these init secrets have to be stored somewhere. So there's a few questions here. There's a few topics here. So one is what to do about Vault masters unlocking secrets specifically. And there's actually a great answer for that. But then there's more like what to do generally about this cold start secret, because it's going to vary case by case on the type of secrets and the type of applications you're working with. And we can't just generalize all that. So with Vault, one of the nice enterprise features that they have now released last year at some point into the community edition is automatic unsealing with KMS keys. So I believe in the Vault Terraform module that's GA on the HashiCorp website, it supports that automatic unsealing with KMS keys. And then it's just a challenge of IAM. So you got to set up your IAM policies correctly to guard control to that. But then let's talk about the other things that he talks about. Like one thing is to have your secrets actually in a GitHub repository in plain text with access to a select few. I think we can all categorically say no to that. We've all learned that this is not a good thing to do. There's an augmentation of this that we see. It's kind of like what you can do is you can encrypt those secrets using the public key that the cluster then has the private key, and the cluster is then able to decrypt these at deployment time. Or you have that baked into the CICD process, and the CICD pipelines are able to decrypt it. I still don't really like that solution too much, The reason why it's not opaque, not that secrets can be opaque, but I mean, here you're encrypting binary data. If somebody is inadvertently, and I'm not saying nefariously, I'm not saying as a bad actor, just accidentally messes up another secret, I approve that pull request. I approve this broken deployment of secrets going out there. I don't think that, is that great either. So ASM, Amazon Secrets Manager, I think has, they obviously thought a lot about this when they implemented it and how it works. So I want to talk about another key problem here with secrets, and that's rotation, right? So you can't just rotate the secret and expect, the cluster not to fail if you don't support concurrent secrets being live at the same time and then life cycling out the old ones. So you almost need to have blue-green of secrets, kind of, or you need to have, for any given period of time, multiple secrets online and working. And this is how, Amazon's STS API works. When it issues the temporary credentials, your old credentials will eventually expire. They don't expire at that moment, and you have some overlap where both of them are valid, and that's to have graceful rollovers. So in whatever solution we come up with here, we need to take that into account. The other is we need to have some certainty of what is deployed and being able to point to a change that triggered it, possibly. And this is where, in an ideal, let's just say, security aside, man, everything would be just so much easier if we could just encrypt these, if we could just have these secrets be in plain text in Git and just have it work with the rest of our CICD pipelines, man. And if everybody was just honest and nobody would do things wrong, man, it would simplify everything. Well, the alternative to this that Amazon Secrets Manager does that makes it so easy is that you get a version ID that refers to that secret. And that version ID imputes nothing sensitive. And in that one, you commit the version ID to your source control, and that's how you roll out the changes. So that gives you a systematic way of doing that. Now, how do we get the secrets into ASM in the first place? I don't have the answer ideally for that. I think some kind of a front end for that integrated with single sign-on would be nice. Obviously, you can still use the Amazon Web Console for that. I think something more purpose-built for that would be nice. And then lastly, I'd like to introduce another concept that I'm finding pretty awesome is the external secrets operator. So with the external secrets operator for Kubernetes, and this is now, again, more of a Kubernetes-centric solution, is that it supports multiple backends, of which 1Password is one of them. And I find this kind of cool because this allows you then to present a really easy UI for the companies and developers to update their secrets. Is this going to work in a mega corporation with 2,000 engineers? Yeah, it's probably not the right solution. But for your smaller startup with 15 to 25 engineers, this is probably going to save a world of hurt and complexity just by using 1Password for a lot of those application-specific secrets. These are the secrets I'm talking about for integration secrets, third-party APIs, and stuff like that. Another option is just get out of the secrets management business together and use something like VGS. This is very good security, and what they become your third party that you entrust to manage secrets, and then you just have tokenized values for everything where you need a secret. You can commit those tokenized values to your source control and deploy your code here, but the secrets themselves are with VGS. And the way it works is basically you export a proxy setting, and that makes your requests go through VGS. Now, would you do this for internal services where they egress and ingress again? No, probably doesn't make sense. But where it makes more sense, if you have third-party integrations that you need to handle securely, this might be an option. All right. So yeah, any other tips on secrets management? Things that you're doing? Andrew, Roth, you probably have some ideas or suggestions.
I posted
Yeah, as
a
well.
link in office hours to Bitnami Labs sealed secrets.
Gotcha. Yeah.
That's what we would be using if we had this problem at the moment.
Yeah, I remember looking at this. Yeah, and this is that same concept basically where you encrypt this. They provide a CLI tool, kubectl, to make it very easy to encrypt the secrets with the public key of the cluster. So you can just commit the sealed secrets to source control and be done with it. Yeah, it's pretty. It's
and then the cluster
nice
decrypts
solution.
it and creates a regular secret inside the cluster.
Yeah. So that's a good tip.
What's a use case for this?
Same one. Basically, you need, let's say you need the database credentials for RDS or something, and you're not using RDS IAM. Well, how do those credentials get to the cluster? So this allows you to encrypt this is a custom resource definition of a type sealed secret that you have this encrypted data that looks like this. So here are the credentials for my service. And then you deploy the operator inside of Kubernetes. And that operator looks for this custom resource that looks like this. And when it sees it, it decrypts it and writes a secret called my secret into that namespace here. So here's the output of that operator. It creates a new resource of type secret where here's the actual password, decrypted from here. So this is secure to put in Git. This is not secure to put in Git, but this is what your applications need to consume.
Yeah. And now this would only be able to be leveraged with Kubernetes.
Yeah, and this is a Kubernetes specific solution. But this is, again, another reason. This is why Kubernetes makes so many things so much easier.
At this point, if you're not already seriously thinking about, starting to move towards Kubernetes as a holistic approach to your entire business, think again.
Yeah. It's like, imagine you could script this stuff. You could orchestrate something like this. You could build something with Ansible, whatever, yada, yada, yada. But whatever you build is going to be a snowflake that won't really work in anybody else's environment. But when you deploy an operator like this operator is designed to work with Kubernetes. So if you have Kubernetes and you like this strategy, okay, let's just install that operator, and now you get that functionality. So ultimately extensible.
So the
DoD is using this.
Oh wow!
Like full scale, 50,000 users.
Wow, that's a vote of confidence right there.
Yeah, maybe. But is very good security then? In other words, is the distinction that VGS is the external to the cluster? In other words, the key.
It is. It's a third party. It's a SaaS service.
Oh, okay.
Yeah, and the idea is that you basically get turnkey compliant. You could say this is like Stripe. So Stripe, all they do is credit cards. Okay. Well, what if you wanted a service like Stripe that works with arbitrary data and any API endpoint? Okay. That's VGS. So you don't have to worry about any PHI, PII, CHD, any of that stuff, depending on how you implement your VGS.
Wow, nice.
So you basically get a token. And they support so your customers can submit the data like through a form, like when you have the post go directly to VGS, so you never even touch it, you never even see it, and then you get back a token that represents that bucket of data that you can now operate with in your APIs.
So what's the story behind this Terraform operator from HashiCorp?
Yeah, so we briefly just covered it.
Did you? I'm sorry, I wasn't thinking.
Okay,
don't worry about it.
Yeah, away from the keyboard.
You missed a great show. It was epic.
Oh, okay.
Full-on demo, all the bells and whistles. Joking. No, it was just really brief. Honorable mention here that it only works with Terraform Cloud because honestly, the edge cases you got to handle with Terraform, I get it why they made it that way, even though I personally wish it just worked with open source edition. There are 3 other operators at least, or 4 other operators for Terraform under Kubernetes that I've seen. But this coming from HashiCorp, I think this is going to be the one that ultimately wins. Unfortunately, it requires HashiCorp for state storage, and it actually uses HashiCorp's remote run capabilities for all the plan and apply. And that's also how it works with approval steps and triggers and all the other functionality that Terraform Cloud brings.
Gotcha. So
But
it's a, you know, kind of a simplified one-stop shop as long as you,
yeah.
you know, sell your soul to us.
Yep. And as a company that's recently implemented Terraform Cloud-like functionality using a generalized CICD platform, in our case it was CodeFresh, it was, it was a lot of, it was hard. And I can't say that we solved it, especially as good as Terraform Cloud, but what we did was get, you know, consistency so that it works like the rest of our pipelines and everything's under one system, and we have full control over what that workflow looks like versus the opinionated Terraform Cloud. One thing I saw that came up, there's a guy, Sebastian, he's a friend of mine. He has a company called Scalar. Scalar has they have a early product here implementing, they've reverse engineered the Terraform Cloud API basically. So you can use Scalar as an alternative for Terraform Cloud. What I think is interesting about that is, you know, the day that Atlantis or some project like Atlantis comes out as a Terraform, self-hosted Terraform Cloud alternative.
And why did they do this? So you don't have to make a contract with HashiCorp, or is it like you pay for it and self-hosted? Is it on-prem or?
So Terraform Cloud, or sorry,
Scalar.
Scalar. So they have their own user base. I can't speak to the business objectives per se, but what they're trying to do is build an alternative to Terraform Cloud based more on open source solutions like, I believe it works with OPA, Open Policy Agent. I believe it allows bring your own container. So that makes it, you know, compelling, since with Terraform Cloud you can't do that.
Sure.
Also, let's see here. I think it's a SaaS, and I think this is actually entirely self-hosted. So I don't think this is a SaaS.
No, it's a SaaS according to pricing at least.
Okay. So yeah, just you know, honorable mention. That's what somebody else is doing out there. There's also Spacelift.io, but I don't think Spacelift implements the Terraform Cloud API.
Okay.
Cool. All right. Well, we are over time here, so I think it's time we got to wrap up for today. I appreciate your time. I think we covered all the talking points. So here's some next actions for you. If you haven't joined the call before, make sure you take some of these, including registering for our Slack team. If you go to cloudposse.com/Slack. We also have a newsletter. Unfortunately, I'm pretty busy. I haven't been able to send it out as regularly as I'd like, but that's cloudposse.com/newsletter. Register for these office hours if you want to get a calendar invite so you can block off the time. I think that's the best way to be a regular on this. So go to cloudposse.com/office hours for that. If you ever miss an episode, you can always go to cloudposse.com/podcast. That'll redirect you to podcast.cloudposse.com, which is where we syndicate all of these office hours recordings. So if you want to catch up on past episodes and learn what we've talked about, that's a great place to go. Everyone is more than welcome to add me on LinkedIn so we can stay in touch. I share a lot of interesting information on LinkedIn, so it's a great way to stay in touch professionally speaking. And if you're interested, what was that?
Oh, sorry. Just a question. You know where you post all these office hours? There's no like summary or description. So when you see like 30, 40 videos, you're like, am I really gonna go through?
Yeah, that's a good point. It's a labor of love. I would love to summarize each of these videos and add that there. I will say that we have the automated machine transcription. So if there's a topic you're interested in looking for, you can probably go to like you do site cloudposse.com, and you do like blogs, or no, and then you search for like Prometheus backend. I think. Let's see if this works. Well, fail here on this one. Anyways, they are searchable from the transcripts, but it's not ideal. I know it's not the answer you were looking for. So thanks for that feedback, though. I'll take that to heart and see if we can't start adding some show notes for each one of these sessions so they're more discoverable. Yeah. And then, yeah, go to cloudposse.com/accelerate or /quiz if you want to find out what it's like working with Cloud Posse. Thanks for your time, guys. See you guys same time, same place next week. Take care.
What was the last thing besides Scalar, or the last thing after Scalar?
Oh, that was spacelift.io.
Okay, thank you.
So yeah, I'll post that in office hours.
Bye-bye, guys. Have a nice
See ya.
evening.
Adios.
Thanks very much for answering my questions this evening. Goodbye.
Yeah, come again.